So, dear students, let's understand what is functions. It is one of the most important topic in C because it allows you to do a small functionality separately in a separate function like main. Main is a main when we write main, and the block of main is itself a function. So like main, we can create our own functions and which can be used in just one line in the main. We all know that main is a primary functions which is required to execute the C program because it is a starting point of the program. So whatever you write in the main, that executes. And if you invoke something, if you want to invoke something, that has to be written in the main. So if you want to run a function, you need to use it in main. So we can create a small functionality outside, but we will be using it in the main function. So what is a function? Function is basically you can is a self-contained block of statement that perform a current task of some kind. If you have a task that is always performed in the same way, then instead of putting the same functionality at every point, we should be making functions and can call by just declaring function name. What happens is this is our main function. You can see this is our main function, and this is our own defined function. And if I want to use it in the main, I am using it as in the main. There's one thing we need to know that that C works on the top to the bottom approach. That it starts from the top and it goes to the bottom. So if we are declaring any function outside the main and that function is below main, in that case, as the C comes, C will at the time of parsing, as a C will come over here, it will not recognize this keyword because this hasn't been used or hasn't been declared above main. So before using any function, we need to declare it above main, or we can use we need to declare it above main, or we can put the entire function above main. But always it is a good practice to keep the main at the top, so that when you will open the file, you will be you can see what is exactly the program is, because main is the main function which will invoke all other functions. So so it is a good, so there is a option that you can uh, declare that there is some function with the function one over here. You can see there is some one function which is available, and it can be found after main. So declaring it, that means that this function will be available after main, uh, like this. So whenever this function, and then whenever the cursor will on this function, what it does, it directly goes to the this function. So it will print function. This is function one, and after this, it will go back again. It will go back to this place because this has been executed. Because this has been executed. So after this, it will print this is the first program with function and return 0. What is return type? We are using the return at many places, you have seen it, and also we are using one keyword. This is int or void many times in the program. So what does it mean? What is the meaning of this? Whenever we write a function, we need to define that what kind of value it is going to return. uh, as if it is returned 0, it considers the function is completed, or if it is 1, that function is successfully completed. In function, if you want to return some value to this function, in that case you need to use return type. Void means that you are not returning any kind of value. If we write int over here, that means that this function will return will return a value which is of integer type. If we write a float, that means that this function will return a value of float type. So we'll study about this later in the coming slides. Let's see now. So important points of the function is, so you can read it out. A function gets called when the function name is followed by a semicolon. And let's understand the function definition, uh, function call, and function declaration. So function definition, we define the function. So this is we know as we are defining the function. It consists of that what our function is doing. First is a function name. This is first, and function type, that is type of the function. List of parameters, which is blank right now. If we need to pass some values from the main functions, we can pass it from here. And local variable declaration, int a. Int a, when you define a function, whenever you define a variable in the function, this variable, the scope of this variable will be the for this function only. After this function, there is no scope of this variable because this is a local variable. Function statement, this is a function statement. This was 2, this was 3, this was 4, this was 5. This is the function statements. So these all comes in the statement, and a return type, return statement. This defines that you are returning some value. So this function is returning a value 0. So these are the block of the functions. Okay, so these are the definitions of the function. When we write a function, and these 6 things we need to consider. So what is return values and their types? Let's understand. Function may or may not send back any value to the calling function. Suppose there is a function that you have created a function which adds 2 values. So what will happen, as it will add the value, it will be the value will be returned to the main function. Like this, that you have a function with the name add, int add, and it will take input. I'll just writing input of 2 values. Okay, and it will add it in a third value, like input of 2 values you have taken in a and b, and the values are 5 and 6. That means the value will be stored at 11. So what it will done, it was in a main, that this was the main function which states that there is a one variable which calls a function add, that I want to add 2 values, and I want to store the value, the answer of these 2 values to in this variable. So what this function it does, that over here we will write return C. In that case, what will happen, that we are returning C, which will give us the value of 11. 5 plus 6, we have taken input of 2 values from scanf. You can from the scanf statement, which is which you all know. So, and let's understand, we have taken 2 values 5 and 6, and under a and b variables, and the output is 11. And this all the sum has been done in C, in the function C, in the variable C, and we are returning the C. That means we are returning the value of C, that is 11. And C is again an integer type. C is an integer type, and we can see that we have written the return type is integer, and we are returning the integer over here, which is the value is 11. So it will return the value 11, and this function, this completely compiles, and it results into the 11. So the value of av will be 11. So this is the return type, that we return the value whenever it is done. So this is return. No, I'm not returning any value. You can return an expression like x multiplies y, a plus b, you can return as expression, or you can return c is equal to a plus b, and c you can return. And this way, like this, that we have returned c, and you can return this way also, that you can small expressions are allowed to do in the return. So basically it returns serves two purposes. On executing the return statement, it immediately transfers the control back to the calling function, and it returns the value present in the parenthesis after returning to the calling function. So in passing values between functions. Right now we did a program where let's do it again. This is a program int main, and uh, okay, let's do it in program on Sublime, which will be a good idea. So let's do a program of function int main, and we'll do one function like int a b c. Okay, I'm creating a function over here with the name add. Okay, and I'm giving the declaration of add int add. We can do this way also. We can add, okay, which defines that here this is of integer type, and this is in which in this function I'm adding two values. I'll take the input of a and b, address of a, address of b. So it will take the value of two value as input, and what I will do, I'll pass it into the, so this way, that I have passed value of a over here int int, that I have passed the two values of integer type. Okay, now int g int k. So okay, okay, come over here, int f. Okay, f is equal to g plus k, and return f. Over here we can print it, printf %d value of c addition. Okay, and this is done. Okay, in the c. So what it does, you can see over here, this is now very clear what it is doing. I have shared two values. I have shared two values. Let's come to this. This is a function. Okay, we'll copy it in the okay. Let's create a new slide. I'll teach you with the slides, you know. So let's copy, let's see this function and understand it. Okay, what is happening over here? I've created a function that is add, which is passing two values. Like this is a passing of values, two values of integer type, and it has a return type of, it is a return, and it is a passing values. Which values is passing right now we don't know. And as we approach to the main int a b c, there are three variables taking the input of two variables a and b. The value of what is our target is addition of two values using functions. So what happens is there is a c, we have called a function add, and we passed now these two values from here, a and b we have passed. Whenever we are passing these values, we need to know that where these values will be stored. So whenever we are passing these values will be exactly stored in the same type of container. Like if the values of these values are integer, then this value will be received in the integer only, and this values are also integer, and it also will be received in integer. So as we declared earlier, that is my return type of integer. So that's why we are that because the its return type is integer, we are receiving the value in this integer. Okay, we will receive the value in integer. So let's come to the function int add int g int k. Right now the values of a and b has been copied to these, and I have declared one local variable, that is f, and these two variables also local. F is equal to g plus k. What is the value of g? That suppose the value of a is 5 and value of b is 6. Okay, so right now it will come 5 and 6. So f is equal to 5 plus 6, that is 11, and it will return what? 11, and this will go back to the c. C, and c will be receiving this, because you can understand that the output of this statement is 11 that you received as an integer. And after that, printf, and function is closed, so it will print the value 11. So this is all about the function. So this way you can understand how the function is working, and how the values are passing, and how the return type is working. So there are four categories: that function with no arguments and no return value, we have seen it. Where there was no arguments, whenever we are passing this, whenever we are passing any values, these values, these values are known as arguments. So this is known as passing values, or you can say arguments. So argument and no return value, with no arguments and the return value, function that returns multiple return values. We haven't done this right now, but we did the complete the four, these three of one three. Okay, swapping a number using a okay, how we swap a number in general. This is the program of it. I'll share the PPT with you in the Google Classroom, and you can understand this is a normal program where it has been shown that one temporary variable has been taken, and first it copies the x, and then it takes the y as an input, and again y is y takes the t. So this is the program in just one function. This is not a multiple function, this is one function, and now we will do it in the form of the function. That how we can do a function, we'll create a swap, where we'll create a function swap, and whenever we need a functionality of swap, we can be using this function. Thus we will pass two values, and the values will automatically be returned. So what happens is, before swapping, like take the input of two values, swap xy, swap xy. Two values has been taken in the main, and it is again now swap xy, means it is passing two values, x and y, and it is not returning any kind of value. There is no return type, that means it's void. And it is must to mention over here also, void swap, I missed it, int int. Okay, so after swapping, you can see the value, second integer, first integer. So int x, int y, again it will the same functionality is repeated, and after swapping, the first integer is x and second integer is y. So this is how the swapping is working. You can you can leave this as it is, because at the time of using pointers, when we pass the pointers in that way, in that sense it works. Otherwise this is no need of it. That's when this printf is working fine, and this is sufficient. So this is the program, you can try it on your own. And okay, we can do it with the pointers also. What pointers is does, so what is the meaning of the pointer? That there is, we need not to return, but it will change the value in the container, because pointers store the address. So here when we pass the address, but value will be remain same. This is the benefit of the pointers. So whenever we are changing the values, at what does pointer do? Let's we need to swap two values, right? What it does over here, यहाँ पर you can see over here again a void integer pointer. It shows that the pointer has been passed because int asterisk is a notation of the pointer. And here what we are passing, what we need to pass, because we all know that it takes the address. So address of x and address of y has been passed as an argument to the swap function, and it has been received into the two variables a and b, and that is both are of integer types. And after returning, so after printf, this value will be, after this, then when this printf will be called, these values will be changed. I'll tell you how this will happen. How this happens is, um, you can understand it like um, there is a value, there is a variable t, temporary variable, that we have seen earlier also. And what happens is, you can understand, this is okay. Okay, take it. What is the value of x is, and let's say 5 and 7. This is x and this is y. Value of x is 5, address of x is 5000, and address of y is 5002. So what we are doing right now, we have passed the address. So over here, what we have received, 5000 and 5002. What it says, that it comes t is equal to value at b. So over here it is a and b, or you can say that it has been stored, the value variable is x and y, but that is stored in the pointer. What it is doing, it is actually replacing the value which is at the 5000 and 5002. It has created one variable, that is t. So what it does in the first column, you can see, and that it has copied the value at b. What is the value at b right now? Which is in y. Which is in y. We will write what we have received. Okay, this is a, this is b. These are the pointers. So what is the value at b? That value at 5002, that is 7. So 7 has been copied in the temporary temporary variable, that is t, and then asterisk b is equal to asterisk a. That means value at b is equal to value at a. What it is trying to do, that it is exchanging the value between those. So it is receiving, the b is receiving the value of a. That means it is overwriting the value of 7 over here, you can see. So now the value at b, that means on 5002, value at 5002 is equal to value at a. So it has been copied 5 over here right now, and in the next iteration it does that value at a is equal to t. That means value at 5000 is 5, and which is, it is exchanging with the t. So over here the value has been changed, and there is no return type. Understand, there is no return type. It is again the same variable x and y, which have the value has been changed. And right now, when we are doing the printf function, when we are calling this printf function, this will show the value, swapped value, where x is 7 and y is 5, because x is still pointing the 5000 and y is still pointing the 5002 addresses. Okay, which means the x value of x is 7 and 5. So this is how swapping works with the pointers. In the last program, you can see that why I said this will not be working, because this will show you that in this program I'm printing the swap value over here, but this will not affect in this line, because the value of x and y over here is the same, but with the pointers it changed, and that too without the need of the return type. Okay, let's talk about the recursions. Recursion is a special case where function itself again and again calls. Okay, it calls again and again, like function main is calling, like in the function main it is calling the function main, and so that means it will keep on looping, it will keep on executing. What is the meaning of why do we need it? Let's come out of the function that factorial is a very famous function where we can get the factorial of a number. Factorial int n, there is a function some main, where the factorial function is being called, and the value which is being passed, that is int n, and it is also returning the value variable of integer type. Factorial states that the how we calculate it: n, n minus 1, n minus 2 till 1. So suppose we need to take the factorial of 4. That means 4 multiplied by 3 multiplied by 2 multiplied by 1, and that is 24. That's how we are going to do right now. In fact, if the value of n is 1, return 1. No need of the factorial. This is the answer. And else, if it is not, that means suppose the value of n is, we are taking it as 4. 4. Okay. 4 multiplied by n minus 1. That is 4 is being multiplied by 3. Okay, and 4 is multiplied by 3. It, what would it will do? It is again a function. It will call this, here is 4, it will call the function again. Understand? With the value 3. Now the n is 3, it will come again. That means, and it is storing in the variable 3. Multiply by, again this will call a function n minus 1. That means 2. Now the factorial 2 will be called. It will go back over here, factorial, and the value is 2. Value is 2 right now. It will come and it will multiply by 2, and it will again 2 minus 1, that is 1. It will go 1, and is equal to 1, return 1. The function ends, and the value of factorial fact is, that is 4 multiplied by 3 multiplied by 2, that is 24. This will be returned. So you can see over here the factorial of 3 has been calculated over here. So this way the factorial function can be used of recursion. Recursion is meaning calling itself again and again like a loop. So it works in this way. It calls it itself. It calls itself. No other function. It calls itself. So it's this is known as factorial. One of the very big, very famous puzzle is the Tower of Hanoi. So what it does, what is the meaning of Tower of Hanoi? Here you can see that there are the three pillars. You can see there's the pillar A, pillar B, and pillar C. Three disk is in the pillar A. What the and the target is, you can see this is the target. We need to achieve the target. But the condition is that if we will move the red, and again if we move the white, so no bigger ring can come onto the above of the smaller ring. Thus this is the condition, and at a time one ring can be moved. So only smaller ring can come above the bigger ring, but bigger ring cannot go onto the smaller ring. So this is where these are the iterations. The first it moves to the C. First you can see the first move was that is C. This was the first move, and then this is the second move, move 2. This is the third move that it has been here, it came here, and this is the fourth move that green comes over here. This is the fourth move, and again the red goes back, again the red goes back, okay, from here, and this is the fifth move, and this is the sixth move that white will be transferred this, and this way we have achieved this. So to program it, you can see input is, if the input is 2, like input is 2, then that means there are, if there are 2 rings, and the input is 3, that means if there are 3 rings. So function states like this, that is our input output. So if the function is input is 2, the output disk 1 moved from A to the B. So we need to find that how the disk will be moved, like over here, if there this is of input 3, this is the input, our input is 3, okay, this is the input which is 3. We have 3 disks. Now how it will be moved? The first move was from A to C. So here we can see that this one moved from A. Let's come to the C because we have seen it in the example. So this one moved from A to C. Come back. What? How the disk 2 is moving? Check over here, from A to B, at from A to B, and now disk 1 is moved from B to C. So disk 1 is moved from B to C. That's fine. No, C to B, C to B, and this way you can find out. This way it is your. Now you have to write a program where this kind of movements you can figure out that how the disk will be moved if there are three, and if there are four disks, then how it will be done. So this is the Tower of Hanoi, which is a very famous problem, and the function has been given over here. This is about the recursions. We are, because the Tower of Hanoi is a function, and it is calling its Tower of Hanoi is a function. You can see, and it is calling again and again itself, and this way it is working. So you can start running, start with the programs. So good luck with the functions right now. Uh, Thank you. If you have any questions, you can leave it on the Google Classroom streams. I'll answer it on that. Thank you.